Welcome to Walk About the Galaxy, the breezy astronomy podcast. Did I say podcast? I think I said podcast.
Broadcast.
The breezy astronomy podcast where the science is universal, the opinions are personal, and the hosts are ripped.
Yeah.
We are Strange Charm, Truth and Beauty, the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Jim Cooney.
And
Zoe Landsman.
whose mere presence elevates Jim from top to truth.
There you go. Not in this house, but yeah.
We cannot trust Jim unless Zoe is here. We are recording today from physically but not socially distanced locations near the University of Central Florida. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms and contact us with hashtag AskWTG. Our stumpers today are observational. I was put in the observational frame of mind by the arrival of my very modest beginner level home telescope, which was a Christmas present that arrived after some back order. And so it's a fun toy.
Whenever I forget to order something for Christmas, I like to just say, oh, it was on back order.
This really was on back order. So Jim, in the telescope theme, reflector or refractor?
Ooh.
I feel like I'm being bottled into one end there. It's got to be reflector.
No.
Because in modern astronomy, we really use reflectors exclusively to build our big telescopes. You could still go buy a refracting telescope, and get a small one, but big ones are all reflectors. And there are some good reasons for that. And my favorite reason is sagging.
Sagging?
Sagging.
You can relate to sagging?
I can relate to sagging. I'm getting older and I understand it now. So I am much like a refracting telescope.
How does sagging relate to reflectors versus, first, just, remind us what's the difference between a reflector and a refractor?
Yeah, so I mean, there are two primary ways to bend light to your will, right? One is to bounce it off of a mirror, that's a reflecting telescope, and one is to pass it through a lens and bend it that way using refraction. And so some telescopes have lenses, some telescopes have mirrors as their primary optical element. The trouble is, and they used to build mainly refracting telescopes, big lens-based telescopes. For Galileo's first telescope and all those early telescopes were all lens-based. But it turns out when you try and build those really, really, really big, there are some very fundamental problems that creep up. Some that are more physicsy, but one is that a mirror-based or a lens-based telescope, I mean, how do you support the lens in the end of a telescope? It's supported around the outside. And any heavy object supported around its outside will sag in the middle, as we know. And so as you move
not us, because
around,
we're ripped.
Ripped! That's right. That's right. But for a telescope that's not ripped, it's trouble. Because those really big refracting telescopes can, the glass can weigh tons or whatever. So that sags down under its own weight. And
okay, so you're going reflector.
That's right.
But I actually seriously my home little new telescope is a reflector telescope. But I seriously considered getting a refractor because on the small end for sort of backyard astronomy, there is still refractors are still viable up to, relatively small size.
Sure.
And they're small, so then you maybe don't collect as much light. But if you're doing astrophotography, you put your camera on there and just let it collect light for a very long time. So the smaller size is not as big of a deal, and there are some optical advantages to the refractor, which are of course outweighed, as you said, although not literally outweighed for the whole mass sagging thing. All right.
Yeah.
Okay, Addie, also in the observational theme, but slightly more abstract, remote sensing or in situ.
So I'm gonna have to go in situ, mostly because that's more of the science I do.
Yep.
Sounds fancier.
Also, because I would like to be taking the measurements. So in situ means you're there, your instrument at least is in the location at which the measurements are being taken. So thinking of like looking down on the ocean versus taking a measurement in the ocean kind of thing, right? Or on the moon, on the surface of the moon, measuring some rocks versus orbiting the moon, right? And there's advantages to each, but I would like to take my little dust detector down to the surface.
So remote sensing's like cameras,
Yeah.
any your telescopes with any different kind of telescope.
Your refractors and your reflectors.
Right. But in situ could be a whole different host, a whole slew of different sorts of things.
Yeah.
Pick up a rock and
there's
put
a
it
lot-
on a scale, that's in situ.
Yeah, that's true. Yeah. Yeah, and there's a lot, most most plasma instruments and most dust detector instruments are by definition like have to be in situ instruments because they're like trying to measure the thing at the location. You have to have a sample of the thing basically.
Okay. So you're in the more in this that on Cassini, half the instruments roughly were remote sensing, ultraviolet camera, infrared camera, regular camera, radio camera, and half were in situ, charged particle detectors, dust detectors, and so forth. And the remote sensing instruments, they're the pretty picture instruments.
It's true.
And the in situ instruments are the squiggly line
You
instruments.
usually get squiggly lines, but they're there, darn it.
So you're a squiggly line instrument person.
I'm very much a squiggly line instrument person, or sometimes just like a dot.
Okay.
But if you're a spectroscopist, you can be a squiggly line remote sensing person.
That's true.
That is true. And I that's the kind I did that as well. And this then brings us to your stumper, Zoe, which is I hope a good one for you because you've done these things, and it'd be fun to hear about some of your personal experiences with both on-site and remote observing.
Yeah. So though I am an observational astronomer, none of the data that I have ever collected to use for my own science has been on site. I've done it all remotely.
What?
I've been to professional telescopes, just not to collect my own data. So with a lot of professional observatories, they're they're in remote places because you want it to be dark, and they're typically like on top of a mountain, for example, to be away from it. Like I work in the infrared, and the atmosphere absorbs infrared light and emits infrared light. And so if you can be above a lot of the atmosphere, then that's great. But it can be like very time consuming and costly to get from wherever you are to some, the top of a mountain in Hawaii or whatever.
In Hawaii, though.
Different
Yeah.
type of
I know.
observation.
So I've done all of my personal astronomy remotely, which in some ways is nice because you can be at home, and I don't know, but it can be a little rough with you're up all night, and then depending on time zones, you might be up from I've had shifts from midnight to noon, which is rough for me. So I think I would rather be on site, because then if you're going to be up all night, you might as well be somewhere cool. But
Right.
But I have visited professional observatories and been on observing runs, and it's really great. The sky is super dark. It's beautiful. The instruments are cool.
Yeah. The telescopes are huge.
The telescopes are huge. And yeah, some people don't do well though for the observatories that are at high altitude. Some people will get really sick. I'm fortunately not one of those people, but I know for some people it's horrible, and they will only do remote observing.
You've been to Mauna Kea?
I've not been to Mauna Kea, so I've been to Roque de los Muchachos in La Palma in the Canary Islands.
Which is
I've
even,
never.
okay, what's the altitude there?
It's a little bit lower than Mauna Kea, but it's I want to say it's maybe 10,000 feet. And Mauna Kea is 14,000 feet.
Is that not the location of the world's largest optical telescope?
It is, yeah. So that's where the GTC, the Gran Telescopio Canarias, is. So that is the largest, visible and infrared telescope in the world.
And how big is that?
Yeah, it's 10 meters. I mean, it's not one, it's an array of mirrors, but it's effectively 10 meters.
10 meters across, 33 feet, which is
It's
the
big.
diameter.
Yes, that's the
10.4 meters.
diameter.
The difference between a backyard telescope and those telescopes is staggering. Seeing one of those things up close is just mind blowing.
It is, yeah.
And all the instruments that go with it, and all the mounting.
Yeah, some of the instruments are like the size of a small car.
Yeah.
Yeah. Well, and I mean, then the other thing is people have this idea of astronomers, like you're going to go to the telescope and like look through it and stuff. But the real people that like know how those things work are like, you stay over here and like don't break anything. You just tell us what to point it at.
You dumb scientists, stay out of the way.
Don't break our very expensive instruments.
Somehow, Zoe, I think I missed what your answer is, though. Remote?
Oh,
or
I'll
on-site?
say on-site. On-site.
Okay.
Also in situ.
In situ, yes.
Right. I've been a couple times, not for my own data, but helping a colleague at Mauna Kea, and it was a struggle. It was a struggle for me with the altitude.
Yeah.
They don't let you use any oxygen at that particular telescope I was. Some of the telescopes there do, but that one doesn't. They're like, if you need the oxygen, then you shouldn't be up here.
Yeah. That's what I've heard.
That's a crappy lesson when you're already up there.
Yeah, then they send you down. They send you down to the base camp that's only at 10,000 feet or so. Yeah. Well, today we will talk about the art of making fake space dirt and what it's good for, retrieving real space dirt from interesting places, and what old Earth dirt tells us about our planet's history. And we have special truth quark trivia. But first, this episode of Walk About the Galaxy is brought to you by the Pauli exclusion principle. Are you feeling crowded out? Are people cutting you off, stepping on your toes, elbowing you aside, and just not giving you the space you need? Then you need the Pauli exclusion principle. Forbidding like-minded fermions from occupying the same state since the origin of the universe, the Pauli exclusion principle is here to keep the chattering masses away from you and carve out the precious solitary space you deserve. The next time you see someone spinning your way, just show them the Pauli exclusion principle and send them off to another state. The Pauli exclusion principle is not available for bosons. Users must be in a quantum state to use the Pauli exclusion principle. The Pauli exclusion principle, everywhere you want to be.
Visa?
Yes. You're speechless.
What? No, we said no. What did you guess, Jim?
Visa.
Go ahead, Zoe.
It is American Express.
Copycat.
$1, Bob.
Diners Club.
It's Visa. Yeah.
Oh, it is.
Good job, Jim.
Yeah.
Right.
Good job.
Thanks.
Wolfgang Pauli won the Nobel Prize in 1945.
I remember.
For that. He was only 45 years old at the time.
Oh, wow.
Wow.
Rare to find somebody that young winning the Nobel Prize in physics.
Yeah. Guess who nominated him?
Wife.
Schrodinger.
Because it's a fun bit of trivia.
I said his wife.
Oh, I thought you said why. Like, because I'm asking you.
Trivia time yet, Josh?
I said so.
Albert Einstein.
Oh.
Very nice.
Yeah.
Who notoriously had very serious problems with quantum mechanics.
Well, he did all sorts of quantum stuff.
Yeah, he did. He laid some of the foundations for it way back in 1905, right? With the
well, even after that, like the Bose-Einstein condensate is a quantum phenomenon.
Yep.
And he was, so the anyway, yeah.
It's
not like he was like, oh, none of that quantum nonsense for me. He was a very leading practitioner of
absolutely. He just didn't like some of the interpretations of it that were going on at that time.
I don't like some of the interpretations either.
Yeah.
I don't like that people.
Probably so are you.
I don't like. Oh, I know. I don't have, just because I don't like it doesn't mean it isn't so.
Yeah. Yeah.
People say I'm likely to die, and I don't like that either.
No, indeed.
Well, space news. There's now like over 1,000 of these Starlink satellites up there.
There was supposed to be like a launch, back-to-back launches with like the fastest back-to-back launches since Titan.
Since the 60s.
60s.
Earlier than Titan, it was a Gemini. In the Gemini program, the Gemini program was designed to test in-space docking for Apollo. And so they launched this uncrewed vehicle called the Agena, some big weird looking thing. And then a Gemini 2-person rocket where they would go and dock with it and undock to rehearse some of the architecture for the Apollo mission. And that was, you know, those launches took place within sort of one orbit of each other, 90 minutes apart. That was in the, like 65. And this would have been 4 hours apart, these 2 Starlink launches, but didn't quite happen this time. But I'm sure we'll be seeing it again because SpaceX has 2 launch pads here.
Yeah.
Yeah.
You know what the launch vehicle was used to launch the Gemini missions? A Titan rocket, which is why
I'm sorry. I'm sorry.
Okay.
I stand corrected. When I think of Titan, I think of like the more recent Titans, but you're right. Yeah, sorry about that.
The astronomers are not happy about the Starlink satellites. Keeping on your observational theme.
Yeah.
Trade-off.
I mean, I saw some report though that they have thousands of used beta testers now or something like that for their Starlink.
Right.
That's cool.
Yeah, there are people getting their internet, their Wi-Fi. Maybe some of them are downloading Walkabout the Galaxy from a Starlink satellite.
Yeah, let us know if you are.
Yeah. Mars arrivals are imminent. The HOPE mission from the United Arab Emirates arrives February 9th. The next day, the Chinese mission goes into orbit, but its rover isn't going to land until a few months later. So it'll scope out the system a little bit first. And then NASA's Perseverance rover lands the following week on the 18th.
So close.
Percy.
Percy.
Venus, on the other hand,
does not have a mission.
Doesn't have a mission, and it was also, everybody had this little bit of Venus fever last
And actually,
fall.
there were some missions.
Sounds serious.
Right? There were some like
Venus fever.
talk about having mission selections.
And there still may be. I mean, I think Venus is still a unfairly neglected planetary target for exploration. But there was a lot of excitement about a potential detection of a biosignature in Venus's atmosphere last fall, and is first reported right here on Walkabout the Galaxy by our special expert guest, Dr. Brad Sandor. Maybe not so much.
Maybe not so much. And there's been a few papers since then that have been sort of counter arguments. I mean, there was a lot of skepticism when it was first put out, and even the paper said there could be other things, blah, blah, blah. But there's been a lot of skepticism, and there's been a couple of papers, and there's a new one that is out by some authors, including somebody I went to grad school with, or I think she was an undergrad when I was in grad school. They grow up so fast. But saying that it probably isn't phosphine.
Right.
What is it?
Yeah.
Well,
Sad.
they don't really say, so that basically the deal is that, like, and I think Brad talked about this a little bit, is like the phosphine detection had to be at like a certain layer and to sort of be in these correct abundances. And so this paper says, and part of the argument for that phosphine detection was that they didn't detect SO2 at a wavelength they expected to detect it at. So there was low amounts of SO2, so it probably wasn't creating the signal at the wavelength they were looking at for phosphine, because it can create a signal there. So they were like, but we don't see it at this place we should, so it's probably not SO2, so it's probably phosphine, kind of thing. But there's this new paper out that says, that sort of shows that SO2 absorption is probably suppressed. So like that line is probably suppressed in the ALMA data that they were using, due to just like atmospheric profiles of how you get absorption and emission lines in Venus's atmosphere. And so they say that probably you can have mesospheric SO2, so in a different part of the atmosphere that sort of accounts for the line that they see. So it's something that you'd entirely expect.
SO2.
Sulfur dioxide.
Yep.
Yep.
You'd entirely expect.
Right.
And if it is
Bummer.
phosphine, it would have to be in a different layer, and it would have to be in like crazy, what was the number? It would have to be at altitudes above 80 kilometers, and at those altitudes it would be rapidly destroyed such that 20 plus or minus 10 parts per billion would be required, which is 100 times higher than the global production rate of photosynthetically generated O2 on Earth. So like It's a pretty unlikely production rate if it was
Yeah.
that.
Right.
So it's an interesting cautionary tale because there was a lot of news coverage of this story when the first paper was published. And the original paper definitely, they weren't saying, oh, we've discovered life or anything like that, but they were pretty confident that they had seen phosphine, which doesn't seem to be the case.
Yeah.
And there's not going to be, news stories about that, which is a great relief to me for all the times I've made mistakes.
Yeah.
Oh, well, at all wrong.
Right. Well, Zoe, you have an intriguing title now, I learned at a recent meeting.
Oh, yeah. Yeah.
You're the
More
chief
intriguing than
scientist.
Beauty Quirk? That's a pretty good title.
That is a good title. I didn't
I have
say it
many,
was a
I have
better
many
title.
titles.
It wasn't a better
It's an
title, but
intriguing one. Okay.
it's intriguing.
Okay.
Beauty Quirk, everybody just knows what that means.
Yeah, obviously.
You are correct me if I'm wrong, chief scientist at the ExoLift Lab.
That is true. That is my title. Yeah.
Tell us what the ExoLift Lab is, what it does, why it does it in 30 seconds or less, and make it interesting.
No problem. So the ExoLift Lab is it's a lab it's sort of at the University of Central Florida. It's actually not technically on the campus, but the point of ExoLift Lab is to develop and produce in large quantities simulated regolith, or soil for the moon and Mars and asteroids. And we recently did a Phobos simulant as well, the Martian moon Phobos. So we make
something that's supposed to be similar to whatever is on the surface of Phobos, which we've got pictures of, but we don't have samples of.
Yeah, that's right.
Observations, but not in situ measurements.
That's right. Yeah. So that was an interesting case. I mean, because so for the moon, for example, I won't say it's easy to make a moon simulant, but we have samples of the moon. There are samples. Astronauts went there and collected them from different parts of the moon, and so we have some ground truth for what the moon is made out of. And so then what we would do in that case is look at the mineral composition of the moon. I mean, we break it down into the mare, the kind of dark parts of the moon when you look at it, and then the highlands, which are the lighter looking parts. They have different compositions. So then we find minerals on Earth that get us as close as we can to the chemistry and mineral composition of the regolith on the moon, and crush them up and mix them. But yeah, it was challenging with Phobos because we don't have ground truth, and actually the remote sensing data is not that great either, because Phobos is very, very, very dark, and that makes it hard to learn a lot about what's on its surface remotely. But so we actually came up with two Phobos simulants because they're kind of two ideas about
Phobos simulant guess A and Phobos simulant guess B.
Correct. Yeah, that's correct. Yeah. So we named them PCA, Phobos Captured Asteroid, and PGI, Phobos Giant Impact. So those are the two ideas for where did Phobos come from?
Okay, interesting.
Yeah. So
what about PDI, Phobos Deep Impact?
Yes.
Coming soon to a theater near you.
The sequel, the long-awaited sequel, starring returning as Capcom.
Oh man, they're making a sequel to Coming to America, and I don't know how I feel about that.
That's bizarre. Yeah.
It is bizarre.
Anyway.
So you're making some regolith simulant. So regolith is the loose material on the surface of something.
Yeah, dirt.
And of Phobos. And who's your customer? Why are you making this stuff?
So we got started on Phobos because there is an upcoming Japanese space agency mission called MMX, Martian Moons Exploration. So that mission is a Phobos sample return mission. That's launching in 2024, and I think the arrival is 2025. And they're going to scoop up. They're going to drill some Phobos and collect some Phobos dust with a gas puff. So they're going to sample Phobos and bring it back.
Are they? They're sampling it. They're sampling it both the puffed up dust and by grabbing something from underneath the surface?
Yeah. So there's the P sampler, which is the pneumatic sampler. So that's getting dust off the surface. And then there's the C sampler, which is the coring drill.
That reminds me, I have to go see the urologist.
I do think that. But yeah, the folks, some of the folks from that mission team reached out to us, the ExoLift Lab, to Dan Britt, who is the PI of the lab, and we worked together to come up with some, as realistic as we can, given what we know, Phobos simulants.
There's also been some Russian missions that have been planning to go to Phobos.
Yeah,
there's one that sort of launched.
There was a failed one a while back. Yeah, Phobos is very interesting. It looks like an asteroid. It looks like a primitive asteroid. It's dark. It doesn't look like Mars, but it's really hard to numerically, from a numerical modeling standpoint, it's hard to get something into the orbit that Phobos is in by capture. It doesn't make sense. So it seems dynamically like it formed from a debris disk from an impact into Mars, but it doesn't look like Mars. So
one of the interesting theories that's come from numerical simulations you mentioned in the last several years is the sort of cycling of material in orbit around Mars between sort of moons and rings and tidal drifting of the orbits, and they come in and they break apart, and then some of the material reagglomerates into moons, so that Phobos that we see now may actually be like the nth generation Phobos, and its original Phobos might have been much larger and looked very different.
Yeah, and I think that's part of the motivation to have these two sampling mechanisms when they get there, so you can see, kind of the stratigraphy with the coring and then just the surface.
Big word.
It's so many syllables.
Do you know how deep that sampler goes, the one that drills into it?
No, I looked this up recently and I've already forgotten.
But it is like a drill and not like an impactor like they've done on the asteroids?
No, it's like a coring mechanism.
I think they've been partnering with Honeybee on that.
Yeah, I know Honeybee is doing they're doing the P sampler. There's a really cool video on YouTube if you Google, if you're brave enough to Google.
Please do not Google P sampler. Tell our listeners right now, don't Google P sampler.
Yeah.
Google MMX pneumatic sampler.
Yeah, if you go to the Honeybee Robotics YouTube channel, then you can see a really cool video of their sampler. But yeah, the coring sampler, I don't remember the details of that one.
Honeybee was actually testing one of their new sampling mechanisms called Planet Vac, where they be on a lander leg basically, and it sucks up dust as you're landing to sample it and to like process it hopefully eventually. But they were testing that when we did a test out with Maston when Phil Metzger and I were for our instrument recently.
That's so cool.
They're doing all sorts of super cool stuff. Yeah.
Cool. And so you've mentioned also, so like, what's it look like inside the ExoLift? If I walk in the ExoLift lab, what am I going to see? Scientists with white coats and, and the bunny suits and everything, with eyedroppers and beakers and Jacob's ladders and things, or?
Yeah, no, it's in a warehouse. It's a pretty messy operation because there is just a lot of crushing of rocks that makes a lot of dust. So what you would see if you walked into the ExoLift Lab would be probably some of our students who work there. So we have a big team of students and they work very, very hard crushing rock. They also do research with us. So they don't only crush rock, but they work hard crushing rock.
Manually, it sounds like a forced labor camp or something.
No, there are machines that there are rock crushing machines. So there's a jaw crusher,
aka undergrads, right?
Yeah. I won't say that no one has ever had to crush rocks with a sledgehammer because that would be untrue.
Also, it's fun.
they actually really get excited if they get to smash things with a sledgehammer. No, for the most part, there are machines that crush rocks. There's a lot of sieving that goes on because one property of various regolith soils that is really important for just the way that the mechanical properties of the soil, the way it interacts with stuff, is the particle size distribution. And so there is, we use sieves that are kind of like, you know, a sieve you might use in the kitchen, but they're big, and we use them to sift the crushed rock so that we get the right distribution of sizes. So all these processes are loud and dirty, and the students, you know, everybody that works in the lab has to wear not just a mask like we wear for the pandemic, but a serious respirator mask because it's bad to inhale such things.
Lots and lots of dust. Well, now I'm starting to suspect why you're such an avid weightlifter. You're been famous for pumping iron, and I'm guessing that it's so you can lug these giant boulders into the ExoLift Lab and then smash them with a sledgehammer.
I know I have to give the students due credit because I personally do very little heavy physical labor. It's almost entirely students, but we do. I mean, so they don't come. We don't get rocks in like enormous boulders. The biggest rocks that we get in are from you know, something you would hold in your hand. So the rocks aren't huge, but like, yeah, there is actually a lot of heavy lifting because we have just buckets and buckets and buckets of many, many kilograms of dirt.
And so the MMX mission is, that's launching in 2024, right?
Yep.
So cool. All right. Well, we'll be looking forward to that. And as you said, Addie, there's been a lot of attempts to learn more about Phobos, and but JAXA, the Japanese Space Agency, has had a lot of success recently with sample returns, so we wish them the best with this.
What's with the lack of love for Deimos? Is that just not as interesting an object? What's going on?
It's small.
It's not like Phobos is big.
Yeah, Phobos.
They're both tiny little moons, right?
Yeah, Phobos is like 20 kilometers, but Deimos is like half the size of that.
Well, these asteroids they've gone to are even smaller than that. Come on.
Yeah, I guess I'm not 100% sure. I think that MMX is at least going to do some remote study of Deimos as part of their whole mission.
They might as well look at it.
Yeah, but I'm not sure why. I'm not sure why Phobos is the.
I mean, I think
favorite
also,
child.
Yeah, I mean, there's just been a lot more. We've been able to study it a lot more, so we have a better idea. And I think there's some theories that there's maybe some material from Mars that's on Phobos because like due to impacts and other things, you get material kicked up and it potentially be on Phobos, so you can actually sample Mars by going to Phobos.
Yeah, and Phobos, like Phobos has been kind of in the discussion as a base camp for Earth to Mars, and then or Earth to Phobos and Phobos to Mars studies or transit, I guess. So I think that's one of the motivations. It's like a stop along the way.
Yeah.
They're both very tiny moons compared to our moon. And one of the interesting things we've mentioned about Phobos before is its orbit. So the Phobos month is shorter than the Martian day, which means that the tidal of interaction between Mars and Phobos is causing Phobos to move in towards Mars instead of outward away from it like our moon is moving away. And that, not the tidal aspect, but that very close proximity to the surface is just what Addie was saying, that it might be coated with some Mars dust. So you've also in the ExoLift Lab make Mars dust, Mars regolith simulant as well.
We do, yeah. We have a few of them. So there's like a kind of generic Mars, but there's also, so you mentioned the generic Mars, but you mentioned the Perseverance mission, the rover that's landing soon. That's landing in Jezero crater. So we also have Jezero crater simulant.
Jezero.
Sorry.
Jezero. If you listen to the podcast, and our faithful listeners have provided us with authoritative pronunciation.
Yeah.
Jezero?
Jezero.
Okay. Well, I'm sorry. I'm sorry that I butchered that.
What's that one's name?
The simulant?
Yeah.
It's JEZ.
Okay. Thanks. I had some other witty thing to say about Percy and Mars Regulus. Oh, I know what it was. Actually, it wasn't witty at all. It's a question. A completely boring, unwitty, uninteresting question. No, seriously, people might think, hey, cool. Sounds like a great Christmas gift for my son. Can I get a jar of fake Mars dirt from the experts at the ExoLift Lab?
Right. Yeah. So we can sell simulant for research purposes, but also for educational purposes. So if it's for an educational purpose, so a school project or a homeschool project or something like that, then we can sell it. We're not supposed to sell it just for random consumption, but if you're going,
right?
Yeah, don't eat it. Yeah,
not for any kind of
not
consumption.
for any kind of physical consumption. Yeah, don't eat it but yeah, we're not because of the way that our organization's set up. We're not supposed to just like sell it for funsies. But
okay, but if I wanted to
learn from it.
If I wanted to do a research project, see whether or not I'm allergic to Jezero crater dust.
There's been lots of fun groups for educational purposes, right? That have been buying it to do like plant growth experiments and can I work botany and grow potatoes on Mars? Kind of thing.
Yeah, that's right. Yeah, we're partnering with a competition group for a competition called Plant the Moon. So there are a bunch of school groups who are receiving some lunar simulant, and they're going to try to grow some crops in there and see what happens.
Are they inspired by the water on the moon?
Supply your own poop?
No, what was that, Jim?
Supply your own poop? That's how they did it, and Matt Damon did it, right?
Well, also, that's where the pea sampler would come in handy for watering them as well. So.
True.
Yes.
So quite seriously then, if we've got educators out there or students who are interested in, dreaming up some cool projects to play around with simulated moon dirt, simulated Mars dirt, simulated asteroid dirt, whatever, they can come up with some ideas and look up the ExoLift Lab.
Yeah.
Contact you.
Yeah. ExoLiftSimulants.com.
Nice. Okay, cool. Yeah. Well, we've gone too long without our trivia, especially since it's a special truthy trivia from
all right, warming up. Okay, trivia. There's no connection between the trivia and the rest of the program, so I'm just going into it. So today, though, there will be a pre-trivia question that you're going to answer now. This one is not available for Beauty Cork because she heard me talking about it earlier.
Okay.
So, quick start. Which was the only Star Trek movie to win a Saturn Award for the best sci-fi movie?
I am embarrassed that I'm not sure what the answer is to this. I don't know if I will ever be able to live this down.
Voyage Home.
Eddie Doe says Star Trek 4, The Voyage Home. Yeah. Josh Caldwell?
Okay, yeah. Boy, I just don't. It's hard.
On this, Josh.
I know. I honestly just don't know. I think The Voyage Home is a good guess, but I will say First Contact.
First Contact, also a good guess. The actual answer is Star Trek 6, The Undiscovered Country.
Well, shoot. That's my sentimental favorite.
That is absolutely my favorite Star Trek movie, even though I've enjoyed very many of them. I think the crowd favorite is usually Star Trek 2, the Wrath of Khan, but I love Star Trek 6. And the reason I mention it, and the reason it's the part of, or it's related to today's trivia question is today, of course, we learned, I say today as we record this, we learned of the death of Christopher Plummer, famous actor. I mean, he was very old, of course, 90-something. But he played the principal antagonist in the movie
Star Trek 6. Yeah, and he was terrific.
He was so good in that. I have never
Shakespeare as the photon torpedoes flew.
Exactly, he's a tremendous actor. Obviously, he's like most famous for what is it? The one with the dancing in the hills.
Sound of Music?
The Sound of Music, right. But he's
The
a
one
serious,
with the music,
serious,
the dancing.
the dancing with the mountains and the stuff. Yeah, Sound of
We
Music.
established
also-
that Jim does not like musicals, so.
Yeah.
Well, he was brilliant also very recently in Knives Out, which was an
Right.
excellent
Yes.
movie.
Right. One
Yeah.
of his last movies. Right. So he's a tremendous actor, and I thought that was one of the best, or possibly the best villain that I'd seen in Star Trek. He's just he was fantastic. But your primary, there'll be several bonuses after at the end. But the primary question is going to be this: which of the following sci-fi and fantasy films, I'm including fantasy films as well here, which of the following sci-fi and fantasy films did Christopher Plummer play in? So I'm gonna read a list of 9 films here, and the answer is going to be yes or no. You don't answer now. Wait for it. Was Christopher Plummer in these films?
Okay.
First one is Star Trek VII: Generations. Next one is 12 Monkeys. Next is The Imaginarium of Dr. Parnassus. Next is Star Wars: The Empire Strikes Back. Next, Howard Lovecraft and the Frozen Kingdom. Willow. Red Sonja. Star Crash. And Big Trouble in Little China. Which of those films had Christopher Plummer in them?
Well, you made up
Okay.
half of those, so.
I recognize that a few of those you may not have heard of, but
So they're either really good decoys or he was in some weird movies.
well, part of it is was an older gentleman, so many of the movies he was in were 70s and 80s, and maybe our
True.
younger audience, like Beauty Corp, may not have seen all these movies, but I have seen the majority of those movies.
Okay.
Okay, so you mull over that, and then we'll come to the bonuses when we get there.
Okay. Well, we won't have too long to mull because our final segment is touching base here on the home planet. We've got a sort of geophysical theme going today, and there was a new story with an intriguing thing about sort of rapid inflationary period for the Earth, where the growth spurt or whatever for the Earth. And I'm like thinking, oh my gosh, the Earth like blew up like a balloon 3 billion years ago or something like that. What's the story on that one, Addie?
Oh, I'm telling it.
I'm putting you on the spot.
It's sort of a fun story. So we have one of the challenging things about studying ancient Earth is that there's so much weathering and resurfacing and continental change, right, on the Earth. So finding signatures from what happened in the ancient Earth is really challenging. There are some places in Earth's crust, though, that have remnants of the ancient history. And there's these specific crystals called zircon crystals that are often found in old rock, right? That actually are really useful for tracing the history of the Earth in this case.
Zircons are like some of the oldest bits of crust, right?
Yeah, and there are very specific crystals that trap, you see a lot of times an analogy to like tree rings, right? Because they have growth rings and they track sort of the history of what the magma was doing when these things were forming, or what the sort of general planetary environment was like when they were forming. So you can do a lot of isotope analysis and dating to really understand a little bit about what was happening in the history of the Earth's crust when it was forming. And it was not just blowing up. It was not inflation like in cosmology.
Yeah, so that's why I got disappointed and put you on the spot.
Oh man!
I was like, what? The Earth didn't blow up and get 100 million times bigger in a fraction of a second?
It was, so they did find a really interesting thing though, which was that they found some rings that were really old, so like 4 billion years old, and some that were 3 billion years old of ancient crust. And so the idea behind this then is, and they were in rings. So the idea is that there were some of the older crust with seeds for newer crust to form around. So if you think about a lot of times when you're forming bigger things in rocks and in other types of in any type of minerals, a lot of times if you have a little seed for things to form around, it spurs growth. But apparently this is true on sort of the planetary scale. And so they think that some old crust helped sort of make the seeds of forming the new crust that we live on, sort of now.
Yeah, like the continents are frequently, people think, and I've fallen into this myself, that like the continents are the crust, but the continents are sort of on top of they're part of the overall crust. The seafloor is also part of the crust layer as well, which is miles and miles thick before you get down to the mantle of the Earth. And so the continental formation is maybe a little bit like water or like hailstone formation. You start with freeze a little tiny thing in the atmosphere, and then that acts as like a nucleation site, and all the water molecules around it glom onto it, and then you get a nice big hailstone. So is
that
this
was,
sort of
that
showing
was
that
what was coming to mind for me too.
Yeah.
That analogy. Oh no.
One thing that I thought was quite interesting about that paper was, I guess that suggests that somewhere around 3 billion years ago, the Earth got kind of warmer to kind of spur this formation of new crusts. And I hadn't thought about that. I always thought that, like, the Earth started out really warm when it formed, and then would be continuously cooling after that. But I guess it's like the radioisotopes, right? So things like uranium and stuff, that the time that it takes them to decay was just such that about 1 billion years after or 1.5 billion after the formation of Earth, it gets a little warmer again because it's releasing all of this radioactive heat. Kind of
it's a really interesting thing. I mean, and if you think about, if you just had one radioactive element in the interior of the Earth, it would also be decaying, just like from the heat of formation of the planet, and things would just continuously be getting cooler because the most decay is going to be happening early, and then you end up, but the decay produces other stuff which can also decay, and those other decaying things might decay more quickly than the stuff that made it.
Right.
So as you work it all out, as you were saying, there was sort of the hottest time for the mantle of the Earth was not 4.5 billion years ago, but this time something like 3 to 3.2 billion years ago.
Yeah, pretty crazy.
Yeah.
I hadn't realized that. I thought that was pretty cool.
And things you can learn from Zircons.
Yeah.
Crazy.
Can you buy Zircons? Can we get Zircons to go with our regolith stuff?
Isn't that what, like, this cheaper like engagement rings? Isn't that
cubic zirconium?
Is that not the same stuff?
No.
Oh man.
Different. A different mineral.
Oh.
Yeah, first it's probably lab made, so it doesn't have any of the fun impurities that, that's all exciting about this. But yeah, I'm sure you can get Zircons.
Probably. I don't have any.
You don't have any. We got to get some Zircons.
Somebody's got them.
If you were making ancient Earth regolith crustal simulants, you might have to get some Zircons in there.
I'm just gonna get some dirt and sell modern Earth regolith.
There you go.
Gonna get from your backyard Earth regolith simulant.
Yeah.
Only $1,000 a gram. No problem.
Jar of dirt. It's going to be the next pet rock.
That's right.
It's going to be a great fad. Okay, Jim, we're ready to.
Regolith mixture.
Oh, that's true. Yeah, you could charge extra for people to have a custom thing. Put some food coloring in there or something.
But most Zircons are really, really, really tiny, so they're hard to buy lots of them.
Yeah.
Womp womp.
All right, my friends. Well, Christopher Plummer, the wonderful, wonderful actor. Which of these movies we're in? Just tell me yes or no for each one of these. We can go through them pretty quickly. Star Trek Generations, the sequel to, or not sequel, but the follow-up Star Trek film to Star Trek 6. Was he in that?
No.
Yes.
No.
Josh and Zoe are correct. No. He died in Star Trek 6, The Undiscovered Country. Spoiler alert.
Well, his character died. There are actors who have played multiple characters in Star Trek.
True, but he did not.
Well, also, they could have had a flashback or something and used it.
Yes.
That's true. I apologize. Just because he died was not a good enough reason, but he did not. 12 Monkeys.
Yes.
Yes.
No.
Josh and Addie, you are right this time. He was in 12 Monkeys, yes. The Imaginarium of Dr. Parnassus.
Yes.
Yes.
No.
2 for 3 each time. Zoe and Eddie, you're right. He was in the Imaginarium of Dr. Parnassus with a whole bunch of other top-notch actors.
Yeah, I feel like I remember seeing him in the trailer for that.
Yeah.
Okay, I guess I have to watch that one.
Yeah, I know. Me too. Star Wars: The Empire Strikes Back.
No.
No.
It sounds like something he'd be in. I'll say yes.
2 for 3 again. Yeah, he was not in that. He was no Star Wars films. How about Howard Lovecraft and the Frozen Kingdom?
Yes.
Sure.
No, I'll be the nay.
2 for 3 again. Yes, he was in that. Howard Lovecraft and the Frozen Kingdom. What about Willow?
Yes.
Yes.
Yeah.
No, he was not in Willow.
Oh,
I
for
love
3.
that movie though. That was so good. I don't know if you guys remember that. Red Sonja.
Yes.
Yes.
No, he wasn't in that one either. Arnold Schwarzenegger was in that one. That was an old Arnold classic.
Never
What
heard
about
of it.
Star Crash?
What the heck was what is
No.
Star Crash?
Yes.
I refuse to
Crash.
answer until you tell me what that movie was.
That was a 1978 movie trying to cash in on the Star Wars money bag.
I thought I knew about all those 1970s cashing in on Star Wars money grab movies. That's sort of surprised.
There were a lot of
I
them.
don't know. I'll say no.
Yeah, he was in that. He was.
Oh, man.
And then finally, Big Trouble in Little China.
Yes.
Yes.
Why is that on this show?
That's what I'm wondering about. But
That had fantasy elements in it.
hey.
A foul. I call foul.
You call it foul? Okay, fair enough. He
Yeah.
wasn't in it anyway. That's fine.
Oh.
Oh man.
Okay, quick bonus questions for you. And this was part of the reason for putting Big Trouble in Little China in there. Which Sex and the City star also played in Star Trek VI, The Undiscovered
that's
Country?
easy.
Oh, I know that
That's
one.
easy.
That's a
Or maybe not.
that's a gimme.
That's a gimme. All right, who was it?
Kim
That's
Cattrall.
Kim Cattrall.
It
Yeah.
was Kim Cattrall, who was also in Big Trouble in Little
Yeah,
China.
That's right. Yeah, that's
Okay.
right.
And then finally, one last one just for fun, because I love Star Trek movies, in which only in one of the first 10 Star Trek movies did Klingons not appear. Christopher Plummer played a Klingon, of course, in Star Trek VI, so the answer is not this one. In only one of those films did Klingons not appear at all. Which one was it?
One.
Of the so the
Of the
original
10,
series,
meaning not the modern reboot versions,
but through Star Trek
through
Nemesis.
Star Trek Nemesis, right?
And so Worf obviously is a Klingon.
Ooh, he is.
So it has to be oh, interesting. So have you guys answered already?
I said one.
I didn't
Okay.
answer. 3. I'm just
They're
making things up now.
definitely in 1. They're definitely in 2. They're definitely in 5. They're definitely in 6. And Star Trek 4, The Voyage Home, they're using a Klingon ship. I don't 100% remember if we see them. And in Star Trek 3, The Search for Spock, oh, shoot, it's 3 or 4. I'll say 3.
Actually, 2.
What?
2.
That's,
Am I wrong?
yeah.
I'm not wrong.
Wait a minute. Do I have my numbers wrong?
What is
The
What?
Wrath of Khan?
There are no Klingons in the Wrath of Khan. They do show up in Star Trek 3, The Search for Spock.
Is it The Search for Spock where Kirk's son gets killed? I was
Yes.
putting that in Star Trek 2 for some reason.
Yes.
Oh my God.
Oh man, I'm embarrassed.
Trekkie
I
card
have
Oh
totally,
gosh, I know what you're
I've
doing this
to-
weekend.
I'm going to watch all this. It's just horrible. It's, yeah.
Gotta-
I'll never let Jim ask trivia again.
Oh, I'm sorry.
Yeah, how do you like it?
Not very much.
Yeah, this is how we feel every week. Yeah.
Okay. While it may have felt like the time since Zircons last erupted from the Earth's magma onto the surface, it was just another episode of Walk About the Galaxy. Write us a review on the back of a raincoat and then wear it while performing a silly dance on TikTok. That should be enough to get us on the late night talk shows, I think. What do you think?
Yeah.
Yeah.
Good.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walk About the Galaxy, where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Thanks to our listeners who happen to be stuck in traffic right now, and to those who aren't. Stay safe wherever you are. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
And I'm Zoe Landsman.
We're the Astroquarks, signing off until the next episode of Walk About the Galaxy.
Phosphine.